We have, in this case as well, h squared plus x squared, also found in this first line. The x squared plus h squared can therefore be replaced by b squared, and we can rewrite that statement by saying that a squared is equal to b squared plus c squared plus 2xc. Now, look at this right-angled triangle that contains the side x and h. This angle is exterior to angle A, the interior angle, A. This amount in the exterior is equal to 180 degrees minus angle A. In other words, we can therefore state that the cos of 180 degrees minus A is x over B, or simply that x is equal to B cos 180 degrees minus A times C. But as you know from a previous tape, any second quadrant cosine is negative the related acute angle A. Consequently, this is equivalent to a squared equals b squared plus c squared minus 2b cos A times C. Written more appropriately, we have that a squared is equal to b squared plus c squared minus 2bc cos A. Solve the triangle in this example given that A is 20, angle B is 38 degrees, and C is 35. A is 20, angle B is equal to 38 degrees, and C is equal to 35 units. Since we have A and C given, drawing a triangle representing the information, we have A equal to 20 and C equal to 35. We draw the diagram to ensure that the angle is in between the given side, and it is. You can therefore use the cosine in this case, and of course it'll be the solution for the side B. B squared equals a squared plus c squared minus 2ac cos B. Substituting, b squared is equal to 20 squared plus 35 squared minus 2 multiplied by 20 multiplied by 35 and multiplied by the cos of B, which is 38 degrees. Using the calculator, we have 20 times 20, which is 400, so we can express the squares quantities there. Now we have cos 38. We'll work out the cos of 38 degrees, and it is 0.788 approximate. So this is equal to 0.788 approximately. I'll write it like that to remind me of what it is, and save writing an extra line. Multiplying then its approximate value by 35, by 20, and by 2 amounts 1103.22 approximately. So we have then that b squared is approximately equal to this sum. If we simplify the details, we end up with 521.78 approximately. Now this, notice, does not give the value of b, but rather b squared. What we must do now is take the square root of that amount, then we will have the length of b, which is approximately 22.843. In terms of the number of significant digits given in the problem, it's acceptable to assume that b is equal to 23, providing no more calculations are performed, are necessary, and so we will use the more accurate result as we continue. We still have to find the angle components of the problem. We don't have the value of angle A, and we don't have the angle C either. Finding one of the angles, of course, is all we need to do to continue with the solution. The second half of the solution to find one of the angles requires that we use the sine law. So in the solution of this kind of problem, where you begin with the cosine law, you always finish off using the sine law. Let's solve for A. There's a good reason why we should solve for A, and I will explain it later. A over the sine of A is equal to B over the sine of B. We could have started with C over the sine of C. That was an alternate choice, but you have no choice but to take the ratio B over sine B in this problem. From this information, we substitute the value of A, which is 20. Sine A, the angle is not known. B is equal to 22.843, which I have just solved. And the sine of B is the sine of 38 degrees, which, if we work out that amount now, is equal to approximately 0.1566. And I'll just do it like this so that I don't have to write an extra line. If I solve for the parts that I have, I end up writing an expression for sine A. Sine A is going to equal 20 multiplied by 0.61566 and divided by 22.843. Working that out on the calculator, it amounts to 0.539 approximately. Therefore, A is equal to the arc sine of 0.539 approximately. Of course, I'm only writing 0.539 on the board here, but I'm going to use the full display on the calculator for what I have for the sine of A, which amounts to 0.539033732. I'll just leave that on the display. And so by calculating arc sine, I end up with 32.62 degrees for A. It's a simple matter now to find the angle C. Angle C is equal to 180 degrees minus the sum of 32.62 degrees added to 38 degrees. Using the calculator again to work out this amount, the answer is 109.38 approximately. So 109.38 plus 32.62 plus the 38 equals the 180 degrees, and the problem is solved. The reason why I chose solve for angle A rather than angle C is to avoid working with an obtuse angle in the solution. You see, for the arc sine of 0.539, it is possible to have two answers. The positive number, The arcsine of a positive number may be in either the first quadrant or the second quadrant. In other words, this answer, as well as being 32.62 degrees, it could have also been 147.38 degrees. But so which one is it? There is a proposition in elementary Euclidean geometry that states that opposite the smallest side is the smallest angle. And so this is the angle which should be calculated first, followed by the angle opposite the middle size side. The largest side angle is then simply calculated by the property of the interior sum of the angles of a triangle equaling 180 degrees. So C, which is of length 35, is larger than the side A, which is only 20, and so I avoided that angle. As you can see, it was a good choice because I ended up with 109.38 degrees, which is obtuse, a second quadrant angle. In another example, solve the triangle that A is 20, B is 30, and C is 45. Small c is 45 units. Notice that in this question this time, we are given three sides and none of the angles. The only formula that we have that involves all three sides at the same time is the cosine law. And so it's the cosine law that is applied here to solve this problem. For if a squared equals b squared plus c squared minus 2bc cos A, then it follows that it will amount to 2bc cos A equals b squared plus c squared minus a squared. And then cos A is equal to b squared plus c squared minus a squared divided by 2bc. And then finding A itself, the angle, is always possible by taking the inverse of arc cos of this quantity. And that is obviously possible since all of the parts A, B, and C are given. And 50. A then is equal to arc cos of b squared is 30 times 30 squared, plus c times, which is 45 squared, minus a times a, which is 20 squared, divided by 2 times b, which is 30, multiplied by c, which is 45. Using the calculator to establish the arc cos of this, applying your order of operation carefully, the top part here is equal to 2525 divided by 60 times 45. That amounts to the arc cos of 0.9352 is what I meant to say. Taking the arc cos, I end up with 20.742, approximately 20.742 degrees for angle A. Next, go to angle B, which is opposite the intermediate length of side, but this time we're going to use the sine law since we have enough information for it. Sine law will have to involve the angle A and its opposite side. And as far as any of the other, and of course angle B and its corresponding side. So we have A over sine A equal to B over sine B. Those are deliberately chosen. A, because you have the information, side and angle. B, because you have the next size of length up among the three sides given. A is 20. The sine of the angle is equal to B, which is 30, over B given, which is not given, and so which is the angle I am going to now solve for. So there are your three components known, and in terms of proportions, that's the fourth proportional which we will have to solve for. Sine B, turns out, is equal to 30 times the sine of this quantity. I still have that amount on the display of my calculator, so I'll simply press the sine function. And I end up with 0.3542 approximately. And that will be divided by 20. So sine B equals this decimal multiplied by 30 and divided by 20. It's 0.5312 approximately. B is the arc sine of 0.5312, and you can be sure that that'll be acute. The arc sine of that, measure of the angle B, which is 32.089 degrees approximately. So finally, the remaining angle C can be found. Angle C is equal to 180 minus the sum of 32.089, 180 degrees, minus the sum of 32.089 degrees, and the other angle, which is angle A, here it is, 20.742 degrees. Using the calculator, and the result is angle C is 127.17 degrees approximately. And so we have the triangle solved. The answers are, there's the value of B, there's the value of C, and here is the value of A. You probably have already noticed that the sine law is angle-oriented and the cosine law is side-oriented.